Morning, guys. I didn't get this done yesterday, sorry. Let's go ahead and finish the histology notes. I think we can do that. And then we'll be able to start talking about bone on Monday. And then on Wednesday, I will post a lecture for you that probably will be a lecture or assignment that will probably be a combination of maybe giving you a little quiz yourself on histology to make sure that you've got it. And maybe I'll start a little bit about bone. I'll have to look and see what I need to do. Okay, so where we left off was we were talking about cartilage in general. And so what I asked is for you guys to look through all of the different cartilages to see if you could see some commonalities and similarities in them. And what is most noticeable about cartilage to me, I was talking about, is that the cells, if you look at cartilage, most of the cells have that bright frame around them. That is the lacuna. That's actually the space in the semi-solid matrix where the cell sits. So we were looking at the fact that that is a cartilage. This is a cartilage. Now sometimes, by the way, you get an empty lacuna and you can't actually see a cell in it because the slice of tissue just didn't happen to catch a cell. And here's a cartilage with the frame around it. Here's a cartilage. There's one. And there's fibrocartilage. It's probably the hardest of the three to see the frame. Here's fibrocartilage from further away. That's what makes it a little harder. But you can still see that sort of the suggestion of a frame around those. So let's go back to hyaline cartilage. Hyaline cartilage is the most abundant cartilage in the body. It is the cartilage that you can feel at the end of your nose if you slide your two fingers down your nose. Once you get past bone, the wiggly part is made of hyaline cartilage. Also, all of your, they call it articular cartilages, well, almost all of them are made of hyaline cartilage. That articular just implies articulation, like joint. The vast majority of the fetal skeleton is made of hyaline cartilage. And you can feel it on your trachea. If you sort of run your fingers down your trachea, that's hyaline cartilage as well. Hyaline implies smooth or glassy, and of the three cartilages, you can't see really distinctly any fibers in the matrix of hyaline cartilage. It does have them. It has collagen fibers, but they're not visible with the staining techniques that they use. So this is hyaline, and that's hyaline. Not at the edge. This is the perichondrium made of dense irregular connective tissue, but this is hyaline. So now let's look at elastic and sort of compare and contrast. Elastic cartilage has visible elastic fibers running a bunch of different directions in the matrix. And so you can look at it again and say, okay, that looks like a cartilage. And then what kind of fibers do they look like? Well, they look like elastic fibers to me. And then this one is elastic as well. It's a little harder to see, but if you look, you can tell that what you're looking at looks like it's got a bunch of fibers running different directions, and they're all pretty dark in the matrix. That's elastic cartilage. This is also elastic cartilage. It's, to me, it looks like the messiest of the three cartilages. This is found in your external ear flap, so the top part of your ear has kind of a bounce to it if you run your finger over it. That is elastic cartilage, also found in your eustachian tubes inside your ear, your inner ear tubes. And then the last cartilage is fibrocartilage, and fibrocartilage has parallel bundles of collagen fibers. It is the strongest of the three cartilages, and you find it where two bones come together with a lot of stress or pressure. So right here, the intervertebral discs are made of fibrocartilage. In addition, there's fibrocartilage between your mandibular condyle and your mandibular fossa in your jaw. And also there's an extra pad of fibrocartilage in your knee, in addition to the sort of typical hyaline cartilage that's found at almost all joints. Your knee has an extra 2 pads of fibrocartilage called your lateral and medial meniscus. So again, look for parallel fibers and a cartilage. So you've got parallel fibers, and a cartilage. Now this one almost always stains blue, so don't depend on it, but if you see a blue one, think it's probably this one. Okay, and then we'll do bone tissue, also called osseous tissue. There's actually 2 different types of bone tissue, compact bone and spongy bone, and we won't learn spongy bone until we get into the bone chapter, which is next. So compact bone is the tissue that you are going to have to label the most on. But let me sort of describe to you what you're looking at. When you are looking at compact bone, you're actually looking, this is a cross section of compact bone. So you're going to end up getting something circular when you look at a cross section of a tissue that has long things in it. So imagine that you've got a long skinny thing and you took a cross section of it. Compact bone is made of a whole bunch of those. Each one is called an osteon, and they run pretty much parallel to one another to make up compact bone. And we will get into this in even more detail in the next chapter, the bone chapter. But if you take a cross section of any one of these, each one of these microscopic structures is called an osteon. And so here's an osteon, here's most of an osteon, and here's an osteon right here. Okay, and at the center of each osteon is going to be what we call a central canal, and the central canal is where all the blood vessels are going to be running. A little arterial will be in there, a little blood vessel, a little vein, and a little nerve is going to be in there. So it usually just stains dark in most tissues, pretty dark here. Here they actually got an empty one, so the blood vessels and nerves are gone from there. So that's called the central canal. And then what happens is around the central canal there are layers called lamellae. So you're starting to see these concentric layers here. And at the edges of the lamellae is where you're going to find the bone cells. And the bone cells are called osteocytes. But the osteocytes actually need a place to sit because the tissue is relatively solid. So this layer of matrix from here to here is called a lamella. Plural is lamellae. Okay, it's more than one of them. And lamella is Latin for layer. So here's a layer of matrix. Here's another layer of matrix. Here's another one. At the edges of the lamellae are cells, and the cells are osteocytes, and they have to have a place to sit because the matrix is solid. So they sit in lacunae. Now, I acknowledge that you actually cannot see the lacunae in this tissue, but it actually is in sort of an open space. But you're just going to have to trust that there is an osteocyte and it's sitting in a lacuna. So osteocytes sitting in a lacuna. And then the last characteristic of this tissue that you usually see is sort of these bicycle spokes that you see running out. Those bicycle spokes you see are called canaliculi, and the canaliculi are actually little canals through this solid tissue that lead from the central canal where the blood vessels come in, out through the solid matrix so that you can get nutrients to each of the cells all the way out. So that's canaliculi, which means little canal, and they are on their way out. So in each of these tissues, in each of these bone slides, you're going to need to be able to label the central canal. Okay, this is a lamella from here to here, and here's the next one. at the edges of the lamellae, you will find osteocytes sitting in a lacuna, okay? And then making the way out to the osteocytes is going to be a series of canaliculi. And then the entire structure, each time you start running into the edges, the entire structure is called an osteon, and you'll have a bunch of osteons in a bone slide. Okay, so that tissue is the most difficult to label, so you're going to have to practice that one. Let me briefly mention what the matrix is made of in bone. The matrix in bone is made of calcium crystals and collagen fibers. You don't have to label the collagen fibers, but it's very much like reinforced concrete. Reinforced concrete has rebar laid down, that would be the collagen fibers, and then a solidifying sort of crystalline structure laid down on top of it, and that would be the calcium salts. And we're going to talk about this tissue again in the next set of notes as well. Okay, and then the last of the connective tissues is blood. Blood is easy. It's easy at this level. It is a fluid connective tissue. It does have a matrix, but the matrix is almost completely filled with water. And then basically it has three sort of chunks in the matrix. And the matrix is mostly water, and then you have these solids, and these solids are mostly cells. So the red blood cells are called erythrocytes, and erythro means red. They're most abundant. You're always going to run into them more than anything else. The white blood cells, there are 5 different kinds. You don't have to know the 5 different kinds yet, but if you've got something bigger than a red blood cell with a distinctly visible nucleus, it's probably one of the white blood cells. So those are called leukocytes, which means white blood cell. And then last but not least, not as numerous as the red blood cells, but still present, is the platelets, which are also called thrombocytes. They're tiny, they're not even whole cells, they're actually fragments of cells. So platelets or thrombocytes. So now let's look at this slide. White blood cells, superabundant. Red blood cells, superabundant. White blood cells, not as abundant, with a visible nucleus. And then thrombocytes, platelets. You can see those guys. And here's a different slide. This is a different type of microscopy, but red blood cells, white blood cells, and platelets. Okay, so that's all you need to be able to label at this point when studying blood. All right, and then the last tissue before muscle is nervous tissue, and nervous